Hello, is this thing on? Is this on? I don't know. Okay, great. Now let's get the other thing on. Hey, how's that? What kind of snacks tonight? I don't know. I didn't get extra snacks, so we have some of the previous snacks. And I had a pretty big dinner, so I probably won't be eating snacks for a little while. If you know what I mean. If you know what I mean. So, we are coming up on a time when we'll probably double the size of the private beta. And before we do that, because I released a beta a couple days ago, as some people who come to the stream know, and nothing really exploded after that. And so there's some small bug fixes for the next one. Here, there's going to be one or two more. But, this is sort of a relatively safe, non-destabilizing beta. And so if we just add some documentation and fix one or two more small bugs, that's probably a good time to add people, So that's what I want to do, is do a little documentation. Now, I took notes at dinner about a philosophical sort of explanation of why the language is designed the way it is with regard to memory allocation, right? Trying to explain how memory allocation goes here for people who come from C++ or C# or wherever. So that might be one thing to do. And another thing to do might just be to do something simpler and more pedestrian that we might actually finish tonight, like talking about how to use the print function, or something like that. Something that's just very concrete and shows exactly how the language works in the specific. So I'm not sure which of these to do. I wonder what people's opinions are on this. Can you imagine you call the function and pass it some arguments? That is correct. We're not speaking of a beta test for the game. No, this is for the next beta release of the programming language, which, as you can see, we release these not too infrequently. So there was one a couple days ago. Before that, it was a couple weeks ago. Before that, it was a week before that. So, sometimes we go 1 week for the next beta. Sometimes we go a few days. Sometimes we go like 6 weeks. A couple times it's been longer than that, or once it's been longer than that. Can you put at tags on individual variable syntax tokens or just on lines of code? Right now they go on declarations only, which is a little bit weird. So you can't really put them on like random statements or sub-expressions or something. And it's worth thinking about if that's useful and how we would support that in a way that's efficient and easy to deal with as a user. Memory management, people are all saying memory management. People are saying printing. Memory for sure. Are there any big refactorings in the plan for the compiler? No, there were, and I've done them all. I've done them all now. There are probably some medium to smaller ones, maybe, but I've done all the big ones. You're interested in printing is how much is there to even explain? Well, there's a few things. Let's start out with the memory management. And if I get tired or feel like I'm not doing a good job, then at least we got a little bit of it done and can go to printing. Because printing I could even maybe start when I'm tired, maybe. How about optimization? We're not worrying about optimization right now. We are not worrying about those things yet. Look, we are doing these things. Okay. Now that I've started streaming, I kind of don't want to do anything and just want to go to bed. Oh, streaming makes me tired sometimes. Okay. I mean, I have some pages. Okay, let's figure out even what file this is. This is going to go in the how-to folder. As long as I even figure that out, that's progress. Even if it's wrong and we have to change it later. Oh. Let's have an easier display. Okay, booleans, arrays, strings, structs, literal types, context. I mean, we can leave the temporary storage first. We kind of need to renumber some of this stuff. We could put this around 200. Right? So it'll go after all those basic types and stuff. But like before the picky details. Nine? No, I don't want to put it as 9. Where would the compile time execution stuff go? Good question. Probably around 300. I want to do some of that soon too. That's another thing we could do tonight. Instead of print is like, here's the most basic meta program that you could do. Do macros not have a file? They don't, because it's new and it's still kind of in flux. And so I haven't really documented it yet. There's a lot of things that aren't documented. So that's also part of what I want to do is just close the gap between what exists and what is documented. Could throw in a file just to brag about compilation speed, but we're not fast yet. So, Are macros separate from code generation? Yeah, it's a totally different thing. How absurdly difficult is it really to create your own language? It's not very hard to create your own language if it's just not that serious of a project, right? If it's like a toy language and you don't really mean for people to use it in an industrial strength way, it's not that hard. And it might be a fun exercise to do as like a learning experience, right? But there's a huge difference between that and doing one that maybe people can actually use to build things with. Not fast yet as compared to how fast a computer is. Save the file. Now it is in. Okay, that's progress. I can check it in. Did I reference any other languages when making the bytecode? No, I just made the basic thing. Like it's not that hard to do the basic thing. It's not that hard. Okay. So let's just kind of outline. I have some things here written in reasonable detail. And other things in less detail. So I have like a page about this. Okay, so I sort of have these are the basic categories, and I have a bunch of things in my notes for each of these. But I want to kind of plan out, because I sort of wrote things down in a not necessarily ordered way, so now I want to plan out what would be a good scope for the essay. If everything is binary, how can you differentiate types? My suggestion is to get more specific with your question. What is a specific thing? What is a specific example of an operation that you would be trying to do where there's some confusion about what types are? And try to think through that. And if you still don't know, then I could answer that question. All right. So I think I want to start by talking about this, and then okay. And then like these can maybe be in this order. By the time we get down there, I think we'll have a better idea of what order to do things in. In qualitative terms, what don't people like about GCs in high performance settings? Is it the delay, the unpredictability, and something else? Both. Both of those. It's the tremendous expense that you have to pay for garbage collection, and the fact that you cannot control that expense, really. Okay. Why can't you design a language where the expense can be controlled? Say if you always choose when GC happens, because what if you run out of memory before you say to do the GC? Okay? Or what if the GC only makes sense, as most GC algorithms that are fast do, if it completes a certain phase? Like, let's just say it's a simple mark and sweep, right? You can't sweep until you finish the mark phase. The mark phase could be quite large, depending. So you don't get any memory back until you complete the mark phase. What if the application doesn't want to give you time enough to complete the mark phase right now? Then by the time you return, the mark is old, and you have to do it again before you could sweep anything. Like, just, I mean, I recommend just actually studying garbage collection if you want to know the answers to these questions. I want you to study garbage. Well, I mean, look, garbage collection is one of these basic computer science things that you should know how it works. You know, it might be a fun project to make one sometime, because then you see it very clearly, right? The new arc collector in NIM is pretty good. Arc is not a thing that you want to use. If arc is not a high performance programming way of doing things. Doesn't Swift use arc? Yep, it does. So an article saying the new .NET 5 is faster than C++, is that possible? It's probably bullshit. People all the time write things that say a thing is faster than C++, and they're almost always bullshit. Start the memory management simple by explaining how parameters are passed to functions. Well, I think that's a different topic. I'm going to write that one down, but I think that goes into a different file. Just a file that focuses on that subject. Because that's a relatively important but also self-contained topic. That is probably something I should write for this beta, though, as well. Guys, everyone every 2 years claims that their new garbage collector is amazing and so fast that everyone can just use it and not worry about it. And it's never true. It has never been true. It is unlikely to be true anytime in the foreseeable future unless computers change radically from what they are today. Okay. So, since I'm kind of feeling lazy tonight, I'm going to outline a little bit more. So the pattern that worked then didn't is this thing where machine language to assembly language to Fortran, then maybe C or something. And maybe I don't know about Ada. I don't know what. I mean, Scheme is just Lisp, but simplified. Small talk, sure, we could put small talk. But actually, no, because I want I want examples of languages that were actually successful at going higher level. Languages that are not that successful, you know, small talk, C#, you know, JavaScript, Java, etc. Right? Objective-C. I don't know Objective-C well enough to talk about it. Shots fired at Smalltalk? I think it's unambiguous that Smalltalk was not successful at being a long-term programming paradigm. Otherwise, we would use it, right? Although, I mean, sort of, I mean, obviously we use like these today, but sort of the really what I'm trying to get at here is a list of languages that went high level enough that performance started being a problem and or became inapplicable for many use cases, right? So at some point you're trading, at some point you can sort of go higher level and you don't really lose anything, but at some point, in fact, we're going to put Lisp here. At some point you just start losing things when you're too high level. Let's put Python in this list. Both can be used on microcontrollers. If you use Python on a microcontroller, you can leave this chat right now. Scala, I don't know enough about. Clojure, no, I mean, this isn't about putting every Hacker News language of the week. We don't need that many examples. Okay, so the ultimate goal of this file is to explain the way this language is designed with regard to memory management, what kinds of patterns of use it encourages what it discourages, and so forth. But to get there, the answers to these questions are, these are not really questions. Are pretty different than most languages. So for these explanations to make sense, we need to explain why we feel the approaches made by most modern languages are wrong. And to explain that, to do that, let's start at the beginning. And talk about what these languages were trying to do in the most basic way. Okay. When digital computers were first invented, they weren't even really programmable in the way we think about programming today. They were built to solve specific classes of problems, and you could set some switches to control the inputs to those problems. Eventually, we invented computers that were generally programmable via a set of machine instructions This was a great breakthrough over what we had before, but because these instructions operated at such a granular and specific level, programming took a lot of effort, and it was very easy to make mistakes, even for programs we consider simple today. Right? Do I know what we had before, or am I guessing? Why don't you read some books instead of being a smartass on Twitchster? Okay. So, sensibly, we looked for ways to program that would involve less drudge work we invented assembly language, was higher level than machine language in that you didn't have to remember the numbers for the different the bit patterns, we'll say. Instructions. Instead, you could use human readable names. And you didn't have to count out how many bytes away the destination of a jump instruction needed to travel, and edit this every time you change the code. Instead, you could give the target of the jump a name and just jump to that name. A program called the assembler would convert these names to concrete values each time you assembled the program. Okay. where do I go from here? Because because this worked out so successfully, we looked for more ways to separate the programmer from the implementation details of the program. We invented languages like Fortran and eventually C. I'm gonna not do the caps thing. Trying to think of what to say next here. These languages automated the generation of assembly language instructions for loops, procedure calls, and in the case of C, maintaining a call stack so that you could implement recursive algorithms without thinking very hard. In all of these cases, in these cases, a little bit of runtime performance was sacrificed. But you were always supposed to at least basically know what your program compiled into on the target machine. I don't know how to say this part. People generally don't read big blocks of text comments that don't seem related to what they want to know. Then those people can fuck off. Those people can go use JavaScript. Because when you're trying to explain something subtle that people aren't likely to understand anyway, you really need to give the justification. You need to lay out the case. That's what we're doing here. Like, we live in a very short attention span culture because so many things cater to people's attention spans, and in so doing, they sort of beg those people to deign to give them a little bit of attention, right? And in that way, they put themselves below those people, and not just any specific people, but below some relatively crass, undisciplined base person who doesn't have that much of an attention span, right? Which, to be fair, is a substantial number of people, but it's degrading. And we've sort of, in society, taken this degradingness for granted, and that's why most of our art is bad. It's why most of our pragmatic things are bad now, and we have to start reversing that trend. Otherwise, we have problems. Because this pattern, programming in Fortran or C, we could make programs that were much more sophisticated in much less time than we had been able to before, and modifying these programs took a great deal less effort. Because this pattern evolved, turned out so successfully, we kept looking for higher level languages to continue the trend. Sorry, I've already skipped Lisp, which is bad. Seems like my audience would already know much of what I'm writing. No. Not really. Not if the language is successful. Kids these days don't know anything. Are you kidding? But also, it doesn't matter if people know something. Like, the important part here is the bridge from what you know to what you don't know, or the way in which these things are connected in ways that you hadn't seen before, right? And you can't do that. You don't get there by not saying the thing that you know as well. Yeah, if you guys aren't willing to read this much, this programming language is not for you. All right. That's all I'm going to say there. Okay. Actually, Lisp took a much bigger leap away from the machine's implementation details than did languages like C. Lisp was always slow and hard to program in, but some people swore by it painfully. And sometimes hard to use. People swore by it to continue the trend. Higher level compiled languages like C and ways to compile Lisp to make it faster, or new functional-ish languages that would extend the paradigm of Lisp into new territory. Yeah, no, if I get too annoyed by chat, I'm just going to shut down the stream. Don't worry about that. I've done it before. Okay. So we got languages like Smalltalk and C++ and Java, and eventually C# and Python and JavaScript and Lua. all kinds of other mistakes. No, we won't say that. It's a little bit too mean. These languages were all attempts to continue the successful pattern of extrapolating to continue the successful pattern of distancing one's self from implementation details of the machine. Do I think there's any value in a language like Python for scribbling down ideas before implementing them in a language like C? No. No, there is value in a language like Python, but it's for non-professional programmers. But even then, like, Python isn't the right thing for that. Which obviously would continue to be a good idea. The problem is sometimes things that seem obvious turn out in retrospect to have been untrue, or sometimes the direction we attempt to extrapolate a trend ends up being the wrong one, and we end up in the middle of some field somewhere with our dick in our hand. No, we're not going to write that. Okay. Okay. So, that's sort of chapter 1 of this discussion. And now we segue to 2. See, these are pretty short for chapters. It's not so bad, guys. That's a good point. I should capitalize fourth. Okay. So next, to talk about what went wrong, to go into full detail about what went wrong is impossible to do here, since each individual wrong path could have many books written about why it's wrong about it. Mention a few here that we build on later. Okay, so we kind of used our will have the most to say about C++, since that is the language that was being used by the designer of this language, being used daily for a couple of decades prior to design. Are heavily informed by these. For a long time. Okay. C++ wanted to treat wanted to make things simpler and easier to program by packaging procedures and data together as objects We will have much to say about this in a different file, I guess, as well. Um, this is not really a scripting language. I would not recommend using this as a scripting language. It's not what it's made for. I don't think scripting languages are a viable idea in 2020 and beyond. They just don't make sense. What's the difference between a scripting language and a programming language? A scripting language is usually interpreted inside the context of like an engine that manages state that the scripting language kind of lives in. And scripting languages are generally less fully featured than main programming languages, and they tend to be more dynamic in the sense of not having strong statically typed variables and not having static type checking. About the code inside the object. You can just use it as a black box. This isn't really, let me stop and reconnoiter, because there's actually, this might be a little bit, this last paragraph might be going a little bit in the wrong direction, right? So let me talk about some things. There is this bet that computers would keep getting faster so we can keep getting slower, right? Bet that objects, constructors, etc. actually help and let you do things extensively. Turns out immutability, functional paradigm, and multiple dispatch are far more conducive to code reuse. Well, you got 1 out of 3 correct. What about OCaml? That's in the Lisp descendant family. Okay. But what I want to get to, right? So you know how if you're doing a maze on a piece of paper, Sometimes you work from the beginning and sometimes you work from the end. We need to work from the end now, right? So we're trying to get to calling new in C++ with constructors and destructors and things like that, or even just mallocing everything. Right? We want to get to like, yeah, these things. Put these with dashes. Maybe an obvious direction is that allocation and initialization shouldn't be intertwined. Yes, indeed. In fact, I have like a page of notes about this. That's one of the things that I definitely want to get to. I'm just wondering, oh, more than one page. I'm just wondering how that affects, like I kind of want to write a whole book here, but we're not going to do that right here because we need to get to the memory part. Like Moore's law is definitely relevant, but like I think we need to pick up this discussion again in another file, right? And offload the general performance parts of it, because what we're trying to get to is memory management specifically. Oh, you also, in theory, didn't need to know anything about the memory inside that black box. You construct the object and it sets up its initial state. You use it and it just does a bunch of memory operations and whatever else. Then you destruct it and it cleans up all the memory. Everybody is happy and programming is perfect and there is no problem. Except, of course, there are lots of problems. Okay, I actually don't quite want to say this yet. I want to say the C++ ideal is for just about everything to be an object, because, and for objects to manage their own storage, and because, and for extra convenience, allocation of the memory holding the base of the object itself. This is a bit of itself and the calling of the constructor are both wrapped together by the operator new, so that when you say new object, you do everything necessary to make a fresh object, to make a usable object without having to think any further, and you get back a pointer to this object. That thing about the pointer is not very good, in fact. We'll get back to it. Before getting back to that, we'll say that this individual objects interacted heavily with the legacy of Lisp and the way algorithms were taught in computer science schools. You make lots of trees, lists, or other kinds of data structures. These data structures all consist of nodes that are allocated on a general heap and can be freed individually at any time. The memory for which is allocated from the reason I'm going so far back and laying out this justification is because what I'm saying is so different. I'm basically trying to tell people, look, the thing that you normally do is not a good idea, and you should cut it out. Right? So that actually takes some justification if you're going to make a statement that strong. Could repeat some points from Mike Acton's talk at RAM versus cache speed. Yeah, we're getting to the cache part in a minute here. That's what I'm leading toward by saying there's nodes everywhere. Okay. So the way they work today, today they have tremendously fast CPUs and huge amounts of available memory. However, relatively speaking, the CPU is much faster than the memory. At the time of this writing, it is not uncommon for a CPU, if it has to fetch a value from RAM that is not already available, to have to wait 500 cycles. Let's say 400 to 5. Let's just say 500 for the value to arrive, which on a CPU that can do multiple instructions per clock means the lost opportunity to do a couple of thousand basic operations just to know the value of one integer. Memory isn't fast or slow on its own. Yeah, it is. CPUs try to mitigate this expense with multiple levels of memory caches. Let's actually make this the start of part 3, because we're kind of talking about something different here. Some caches are very small and close to the CPU and thus are very fast, but bigger caches are necessarily further from the CPU and take correspondingly longer to read. modern CPUs go to heroic levels of effort to predict which memory your program will want in advance so that it can have that memory in a fast cache before you need it. When this prediction succeeds, your program blazes along very quickly. When this prediction fails, your program grinds to a halt for a bit while it waits for that memory to show up via the bus or some other slow public transportation. I didn't write books in my 20s. I did write short stories in my 20s. You're learning C++ and you're considering which engines to use for game development. What would be my choice? It doesn't matter. If you don't know, you don't know. Just mess around. It doesn't matter. Okay. Memory to arrive. Because the penalty for failure is so high, these days, to a first approximate, let's just say the performance of most programs today is largely determined by the degree to which they do not miss the cache. Try to read memory that the CPU didn't know in advance that they would try to read, they would want. This is very different from the olden days when the number of instructions that were executed determined the speed of the program. See, I'm going into this detail, but this is even just the performance argument for not doing memory allocation in this way, but there's also like complexity arguments and so forth, which we're probably not going to get to tonight. Yep. Okay. Would it be possible to have an architecture with one or more cores dedicated only to rearranging memory to fix fragmentation? You're assuming there's a right answer. What if there isn't? And also the answer is probably no, because Um, because of this. Do I think I'd ever do a Kickstarter for what? I doubt it, but I don't know. A game? Probably not, because the problem is, like a really successful Kickstarter today for a game is what, like $1 million or something again? And in return, you suddenly have all these obligations to the people who gave you your $1 million, which, by the way, is a paltry budget, even for the size of games that we make at my company. Dude, we can't do anything with just $1 million. So you're taking on this huge weight of managing people's expectations who paid for something that they may not get for a while. It's just not a good trade. If you are going to do that kind of trade, you want to do what like Star Citizen did and move off crowdfunding and run your own thing and just give people, you know, in-game promises and whatever, right? What was the budget for The Witness? I don't know exactly. It was probably a little more than $6 million. Somewhere in there. And that was back like 5 years ago when $6 million was real money. Do you actually get $1 million, or does Kickstarter and government take half? I'm not sure about the taxes thing. Kickstarter definitely takes a cut. 6 million, that's like 30 braids. Yep. Yeah. I mean, to be fair, the game, like Braid, I always thought of as like a 5-hour game. Maybe it's more than that. I don't know. Witness is like 40 to 100. So just by content, Witness is at least 8 braids. So it's not like 30 braids of budget is that far. Considering it's 3D, that's actually not that bad. Do you think the common advice of you're never too old to start applies to making games as a solo programmer? Yes. I mean, look. What else? You have to do something with your life. What else are you going to do? What's 30 braids in decibels is what you guys should be asking. Please don't tell me people commonly beat The Witness in 40 hours. I sure didn't. I don't exactly know. 40 hours is, in my mind, 40 hours is a somewhat fast but not totally blazing playthrough of the main line of the game to get like maybe the most of the lasers and get through the mountain and get to the end. And again, that's an estimate. I don't actually have stats on how long people take. I wonder if Steam makes those public. Like, I wonder if you could look at how many people have the end game achievement and how long they have in playtime. Anyway, though, of course, some people are just blaze through puzzles and other people take their time and all that. And then, but I think of it maybe as being 100 hours if you're going to be completionist about it. Maybe it's more like 80 for a completionist. I don't know. But again, those are all just numbers in my head. What would my advice be to those people who want to build and ship a game with no experience besides general programming for GitHub's Game Off, which runs from November to December 1? Well, I mean, you're not really shipping a game for a GitHub thing. You're just like making a game. Like, I don't know, just have fun with it and try to learn. Do your best. It's just a jam. It's a game jam. Do people speedrun The Witness? Yeah. I mean, it's not the most thriving speedrun community because it's a single player puzzle game. Which doesn't tend to be the most speed runnable, but definitely there were people putting in speed runs and refinements on them. How to Beat claims 43 hours for completionist. I don't believe that. I doubt that most players would 100% the game in that time. That sounds too small to me. What mentality do you need to ship a professional game? You need to be willing to do whatever is necessary to make the game good, regardless of whether or not you think that is in your job description or what you signed up for. Was that puzzle made that long specifically with speedrunning in mind? No. Yeah, 45 hours, and that's all lasers end game, but definitely not 100%. Yeah, I mean that's what I think if you're doing lasers, 40 something seems probably about right for people who are pretty good at puzzles. Again, you have to keep in mind people who aren't that good at puzzles or not even not good at puzzles, but don't have that much experience playing puzzle games. They might get stuck on a puzzle for an hour and just, I've been stuck on puzzles for an hour in games. So if that just happens 10 times, like that's 10 hours. And if there's enough puzzles in the game, that could easily happen 10 times. Chat's really going by now. Do I have any opinions on CDPR stance about being transparent and don't bullshit consumers? I don't really know what that is that you're talking about. Do I think I will make a non-puzzle game in the future? Yes. You got physically stuck in the swamp. Yeah, that could happen. How do you raise money for a project if you don't want creative compromise? It's very, very difficult. You either need to have friends who are rich or you need to work and save up the money. That's what I did. There are a handful of things that solo game programmers should focus on getting good at when starting out, or just make a game and get good at all of it. I mean, just make a game and keep an eye on getting better. You have to intend to get better. That's the important part. You have to judge your performance and attempt to improve it. If you don't do that, you're hosed. If you do that, The details actually don't matter so much. What are my thoughts on YouTube game developers like Danny and Thin Matrix? I do not know those people, so I can't say anything about it. I assume that they're YouTubing development of a whole game or something. I mean, I guess that's cool. Sounds cool. How much before you can retire and work on games full time? I mean, for Braid, I had saved up a lot. I think I saved up like $120,000 for Braid or more. Um, and then I spent all that making the game, and then did some contracting and got a loan to finish it, so that the total budget was over $200,000. But that that was in 2006 money, when $100,000 was real money. Good thing Braid was a success. I know. I know. That was expensive. It was cost to pay people to work on the game, as well as living expenses. If you save $50,000, move to Alabama and eat beans and rice, you'll have plenty of time to make a game. Oh yeah, I mean I'm funding a game right now made by someone who lives in Tennessee, and uh, his budget is not high. You know, I made Braid living in San Francisco. It was a lot more expensive. Do I think using Unity Unreal would reduce budget? It depends on what you're trying to use them for. Some things like a 2D game like Raid is not that hard to program. Um, like it's probably approximately as hard to get Unreal or something to do what you want as it is just to program it. Um, a 3D game is harder because you have to learn a lot more, and there's just a lot more work to do. Did I ever struggle with getting too attached to my game ideas? I don't know. It's a weird question. Did Notch have a job when making Minecraft? I don't know. You'd have to ask him. Okay, we're getting back to this. Ways of writing programs as encouraged both by computer science school and by object-oriented paradigms is that they make it very hard for the CPU to know in advance what memory you will need. Imagine you have a linked list that is 2 nodes long, and you want to know, and you want to get at the data, let's say 3 nodes long. You have the first node in cache, and you want to get at the data inside the 3rd node. Let's do some ASCII art. Pointer What a wonderful drawing. So the CPU, yeah, this is hard to explain. You first have to convince people that the performance gains you would see by being considerate of these issues are actually worth what they see as an extensive amount of mental effort. Well, I mean, some people are just... Some people just... I mean, it's not like these people thought very hard about what to program in and weighed all the options and picked one. It's like, no, they just learned what they learned, what they randomly came upon. So for many of these people, if you just become a programming language that people use, they'll use it. Like, I don't know. I don't quite see that as the hard part. Link the YouTube talk in the docs. Yeah, well, there's a whole talk that I want to do that doesn't exist in a recorded form yet. That would be more relevant to this. Unless you mean someone else's talk. Step A takes a long time because B was not in cache. Step B then takes a long time. Oh, because number 2, because number 3 was not in cache. But wait, can't all the work the CPU does, can't this be sped up by all that prediction work the CPU is doing? Not really. Not really. The problem is there is no way to know in advance which memory to fetch for number 3. It depends, after all, on the pointer of number 2, which will take time to retrieve. We don't know we want number 2 until we decide to follow pointer of number 1. We may be able to predict that part and fire off and start pulling number 2 into cache before our CPU's program counter reaches the instruction for A. But there's no way to predict B until number 2 is actually in memory, and that takes a really long time. This seems like a this seems like a very special case example, reading 2 links forward in a linked list. But in fact, Lisp programs do much worse than this with great regularity, and object-oriented programs create equivalent situations and much worse by following pointers between objects all the time. So we're kind of getting to the point, right? We're on line 175, and we're kind of getting to the point now. Yeah, overly specific, like yeah. Not even overly specific, but like, I'm trying to say, it sounds like an example that is such a particular case that you probably don't have to worry about it, right? Let's say very particular. That's, I don't know. Niche. It sounds like a very niche example. Contrived, not really. I don't think it's contrived. That contrived was the first word I started to write, or no, I started to say convoluted, I guess. But contrived is not really like, you do a double pointer follow a lot, even explicitly. Okay. Can you do object-oriented programming without storing everything on the heap using a bunch of unions? No, you cannot, because, well, I mean, it sort of depends. Probably not. I mean, so the first thing is you would have to make the decision, where are you storing the virtual table of the object? And if you're storing it in line with the rest of the object, which C++ does not do, then you're sort of saying there's a maximum limit to the number of member functions you could have that are dispatched through that V table, which seems very undesirable, because that kind of expansibility is supposed to be the whole idea. And so then maybe the virtual functions are outside, but then you're chasing that pointer all the time at least, right? Which is not so great. But then also, if you put things in a union, you're again saying there's a maximum size to this object, and nobody will ever be able to subclass it, right? And then also you're kind of getting rid of the constructor-destructor thing. Because it's a union, the programming language can't really construct or destruct it. So you have to explicitly do that. And that's kind of against object-oriented as well. That's why things tend toward Swift is doing something simpler to OOP, but on the stack. With the Swift UI framework, views are all value type objects that only exist on the stack long enough to be rendered. I mean, sure, but why are they objects at that point? That just seems goofy. Like, that's just what a C program does. Why are you pretending they're objects? Like, so it might be good to include an analogy of a cache hit versus RAM. There's I could put a link to the thing. Does anyone know where the thing is on the internet about different computer speeds? Right? It's like the solar system analogy where the hard disk is like going to Jupiter or whatever. I could link that. Numbers every programmer should know. This is 2012 even, so these numbers are going to be higher for, yeah, like, yeah. So this is about 200 cache misses. He doesn't even have like integer add on here, so that's a little weird. Anyway. This actually isn't the one that I was thinking of. There is actually one, there's actually a file somewhere where someone's like, look, imagine that the CPU registers are like your desk in front of you. Does anyone know that one? Oh yeah, this one. I mean, these are not even... Like, there's no integer op on here either, which is kind of silly. Simple register op. Yep, less than 1, that's correct. Memory write approximately 1, but that's because it's buffered, right? It goes into like a write queue. Main RAM read. This is not correct. I don't know why people are saying 100. It's not 100. It's like 400 or more. I don't trust these numbers. Like, they didn't actually measure these. No, it explicitly says 100 to 150 in here, which is not correct. That's a very old number. Why are people linking me things and I don't even know what they are? Like, why does this not have integer operations on it? Why do all these people ignore integer ops? That's important. Ah. Because they're HPC people. I guess high performance means you can't use integers because they're too high performance or something. Okay. You guys are not telling me. Oh wait, somebody linked this one. Okay, I like this. I like this changing it to human scale, right? So if a CPU cycle is 1 second, it's easy to imagine 1 second, right? Main memory access is 6 minutes. 6 minutes is a lot longer than 1 second. Yeah, see, and these are even accurate numbers. So this is like, 120 divided by 0.3 is a little over 400 cycles, right? It's exactly 400. See, I told you it was 400. Yeah. This is a very ugly diagram. Registers, on-chip cache, onboard cache, memory. So if the registers are right here, main memory is like a different city. Or the size of your city, I guess, in the analogy. Okay. And then this one, yeah, okay, that's just included in. Okay. Most people don't even understand how far away Pluto is. That is true. It's really far. It's really far. Okay, I'm going to include this link. And this link will go to help you understand the magnitudes of the speed differences. See that. Okay, good job, chat, whoever posted that. Most people don't even understand how far away the moon is, yeah. Extremely detailed paper on memory written for programmers. You can see by way of these analogies that in the modern day, the idea that some of these languages have of eliding the implementation details of memory layout can be extremely costly. They aren't just a straightforward extrapolation of going higher level. The step from machine language to assembly language was phrase this above paragraph better. It's kind of clumsy. I'm getting toward the end of the stream, so I think I don't want to think about this too much right now. Okay. Actually, this could be the beginning of section 4. Most modern languages are built around this idea that the programmer should not have to worry about memory allocation and that the task of allocation should be hidden. They all do this in different ways. C++ and other object-oriented languages fold allocations behind abstraction barriers. Lisp descendants use a garbage collector so that you never have to worry about freeing memory. Swift and whatever else use arc for automated reference counting, which is a way of automatically guessing when you are done with memory, then freeing it. All these approaches have different kinds of performance problems, but they all share one thing in common. They encourage you to think of your data as a bunch of separately allocated nodes, but that is exactly the slowest thing you can do today in the year 2020. But this is the way most people have been taught to program. They don't even think twice about it. That is the point I was trying to get to. How is ARC different than GC? It just tends to be more local. Like technically, if you go back to older computer science papers, reference counting is considered a kind of garbage collection. But I feel that it's different enough in character to put it in a separate category. Is ARC like a smart pointer? Yeah. Yeah, it's like a shared pointer or whatever. Is Lisp really that slow? You imagine that they optimize it using pooled memory. What does that even mean? Okay. if that's slow, what's fast? Well, the easiest thing for your CPU to predict, well, one example of an easy thing for your CPU to predict is iteration over some array. I'm going to get my awesome drawing again. Whoops. Pointer A, pointer B value, right? I don't know. Maybe not even pointer A, pointer B. Okay, this is just some data structure, man. And you're iterating over this array in a for loop and looking at each node. The CPU will predict that will notice that you are viewing memory in a linear pattern and fetch future pages of that memory into cache. So this kind of iteration will be very fast on modern CPUs. Something that looks a lot like this but is much worse for performance is when you introduce pointers again. Suppose you're in one of these languages where values are boxed for purposes of garbage. I don't know. That's starting to get a little too implementation detail specific. Languages. I think Java does this, right? In Java, isn't everything a frickin' pointer to everything else? To objects through pointers. So an array in one of these languages would look like this is going to be kind of hard. I just wanted my nodes to be closer together here. Let's put another. Except this being a computer, the actual values you care about, float, pointer, integer. Saying pointer is weird. How about gonna say string, float, string, integer. Except can be much further apart, can be tremendously much further apart from each other, and if the array is long, very much more scrambled. The CPU can try to prefetch these since it can at least see all the pointers in the top level array, so it at least doesn't have the kind of double dereference dependency we had in the linked list example, but the prefetching is going to be very inefficient because a lot of waste data is pulled into the cache. Good suggestion. Okay, so performance isn't the only problem. These techniques introduced by some of these languages also make your code more complicated and harder to understand. And that's going to be, I think, the next section. Wait, what? So this is the part where I really want to think about it some more too. Boy, there's a lot of stuff we didn't cover. I'm actually not sure. So for the harder to understand thing, I really sort of want to talk about the object-oriented mindset again, right? But I feel like I'll do that later. Like it might be break time. How long has the video been, or the chat been, or the stream been? It's been, we're going on 3 hours, which is, you know, that's significant. We could continue this later. Are there any like questions or elaborations on what we've written so far? Anyone? 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 Still not sure why I'm writing this. So what this is it's going to talk about why this programming language is the way it is with regard to memory allocation. Okay. And so I'm making the case that, because a lot of people are going to come along and say, oh, I was taught in school that blah, blah, blah is good. And I'm trying to explain why blah, blah, blah is not good. And therefore, decisions were made a certain way. Here's sort of the common patterns of memory, right? Would I consider publishing these essays apart from the compiler? Maybe at some point. Yeah. It's way too early for that right now, though. Can you just rant about your lecturer said he always includes member objects in his classes by pointer so that he can forward declare them to avoid including headers for them. I used to do that all the time. Like, if you're optimizing for compilation speed, that's a good idea. But it has a serious runtime cost. Isn't that just depressing? Yes, it is. And do you have to make that case since C got you covered on that already? No, everybody thinks that C is an old paradigm that we are far past now. And part of the case that I'm making is no, we're not actually very far past it, because most of the territory we've gone into after that is a mistake. That is actually a very difficult case to make convincingly. That'll require much more than just this essay, right? But this essay is explaining the part of it that's specifically about memory. Do I have a good video or discussion on how OOP classes can contribute to cache misses, etc.? I mean, I literally just said it in this thing that we just did. I also said some stuff in my Barcelona talk in 2018 that's on YouTube, but it is basically the same as what I said here. In fact, this might be more detailed. I don't know. Do I have an inherent problem with GC? No, GC is fine for people who are not professional programmers. For people who are like doing other jobs and they're just trying to make their computer do something, GC is fine. But if you call yourself a professional programmer, you should not use garbage collection, period. Are we getting more of these streams this week? I don't know. Like, this one was honestly, like, chat can be really frustrating sometimes, especially if I'm trying to think and be in a positive mood in order to write things. So we'll see how I feel, right? I'm definitely going to write a bunch more documentation over the next couple days. But we'll see. What are my thoughts on the main introduction to the language being largely referential, responding to popular languages rather than just selling its own strengths? Because you have to communicate to people and you have to talk to them with reference to what they know. Otherwise, I'm just saying, oh, it's really good, trust me. It's like, what do you mean it's really good? You don't even garbage collect, bro. What are you doing, right? It's like, no. I have to explain why I don't garbage collect. And yes, in some hypothetical future where this language wins a very good audience that don't need convincing anymore, then some of this prose is not that useful to that audience because it's historical. But you need to get to the point where it's historical. That's not necessarily easy. Yeah, the frustrating... Why did it just say get bits on my own channel? Yeah, the frustrating thing about streaming while writing is everybody telling me I'm doing it wrong. It's like, guys, thank God that people don't do that while I program, or I wouldn't stream programming. Oh my God. What are the reasons for using this and not just using C99? Well, I mean, again, that's not really a topic for this particular essay, but again, you do want a higher level language. Like that thing that we talked about in the beginning of wherever it was, assembly language and going higher level from that, that is a real phenomenon. And you want to continue that way. You just want to continue the right way and not the wrong way. Yeah, like defer free is going to go in this section as a pattern, and you don't even need macros for that, honestly. It's just that's a very like you often want things scoped locally, and so just do that, right? There'll always be people who will tell you you're doing it wrong. It's a good thing. It means you're bringing new people in. Yeah, I mean, some of these people are not even new. Some of these people have been on the stream for years. Um, no, it's fine. Like, look, I wouldn't be where I am today if I listened to people who said that I was doing things wrong. In fact, last year, uh, when I was in Taiwan, I gave a speech about some of the criticism I got for Braid, for the design of Braid, and everybody telling me I was doing it wrong. Like, you have to know that what you're doing is good, and know what it is. Um, but it's just like, so it's not that exactly. It's just like, why would I voluntarily open up a channel to have people say that to my face when I could be off at a coffee shop writing in peace, you know? Like, that's all. Writing essays is easier to follow versus writing code, hence you get more feedback. Yeah. And also, people don't, like, what they're imagining I'm trying to do is different from what I'm actually trying to do. Like, I'm trying to make a very, ultimately, of which this is one piece, I'm trying to make a very long and nuanced argument, right? And this is trying to be a piece in that argument. Do I think if everyone was forced to program in a language like this, ignoring time to learn the language, there would be any noticeable productivity change? Well, I don't think that's a good idea. Certainly not everyone, because again, I think there's a difference between professional programmers and not professional programmers. Whether there would be a productivity change, I think that radically depends on who you're talking about. Like most programmers by profession today, most people employed in the profession of programmer just aren't productive. Like, they're not productive in their current language, but the language isn't actually the bottleneck. I mean, sometimes it is. If it's like JavaScript, it can often be a substantial part of the bottleneck. But the bottleneck is really that they're just not productive and don't want to be productive, because if they did, they wouldn't be in their current job, or the job squished the spirit out of them and they would have been productive once upon a time and they're not anymore, and they have to learn how again, right? Um, would there be productivity increases among people who are in productive situations? Maybe. It's just hard to see. Part of the whole thesis, though, like, this is part of a very big thesis, and part of that thesis is that of the software that we have today, 95% of those lines of code shouldn't exist, right? And so that's like part of the theory that requires a lot of explanation. Um, if we didn't have to write that 95% of other lines of code, yes, we would be a lot more productive. Um, but that's not just about what language you use, because there are other factors, right? Like, you could use C++ and still write software with many fewer lines of code than we do today. Like, for example, this compiler, is not that big for how much work it does, right? It's a C++ replacement language. It's 53,000 lines of code. Um, that said, there's no optimizer. We lean on LLVM for that right now, but that's pretty small for the feature set that's packed into the language. It's just a way of proving that these things are possible, right? All the job offers made your soul twinge. Well, it's good. It's good not to take those. Because riding in a coffee shop, you get wrist pain. Well, that happens in hotel rooms also. Is this just for game programming, or do I think those are accurate for more general programming? I would describe this as a systems programming language. So for any kind of real-time system, it's a very good programming language. For other kinds of things, well, I mean, most programs are interactive and want to respond interactively, right? So, like almost every program on your phone is interactive. So these are the kinds of programs that this language is meant for. It started as, like, games is a good discipline to help make sure that the design decisions made in the language are actually useful and good and keep it real, because we're building a very complicated thing, with, like, building a very complicated game is a good test of the language. It's better than people's usual test of programming languages, which is like a compiler for the language or whatever, right? But yeah, there's nothing game specific in it, actually, right? It's not like, game maker script or whatever. It's not like that. Do I think self-hosting or not relying on LLVM would happen first? I do not actually know. Probably, I mean, so these things are a little bit of a sliding scale. I would say we would have some degree of optimization first. So way before self-hosting, we will have an optimizing compiler to some degree, right? Is that competitive enough with LLVM that you could switch that to be the default path for release executables? I don't know. That depends on work that is yet to be done, right? But that probably happens first, but I'm not sure. Like, that's not a very serious roadmap. Is there a threading model? No, there is not. So many big companies complain that there aren't enough C++ programmer, and that is why they use other languages. No, that's a lame excuse. That's a lame excuse. What they're really saying is they're hiring people who are at a pretty low skill level. And or they just want an excuse to use other languages. I don't think a lot of big companies say that. I think I've heard one or two say that. You're a bit confused by the specific term data locality. Maybe you're misunderstanding the term, or it's just a heuristic bad term, but it's not like moving your random walk cache misses to less distant memory addresses changes anything unless it is on the size scale of cache lines. Am I right to assume that memory access order is more important? Okay. When you're hitting cache most or all of the time, I'm not sure if this is the answer to what you're actually asking, right? And I'm actually not sure. Did I use the phrase data locality or did somebody else? I didn't use that. So that must be somebody else's term. I don't exactly know what they meant by that, so I don't know if that's like a standard data-oriented design term or something. But here's the thing, right? at first you're constrained by just sheer quantity of cache misses, right? Because every cache miss that you actually have to block on takes that amount of time, right? Once you're no longer mostly constrained by cache misses, you are constrained in many cases by memory bandwidth or by, the depth of, this starts to depend on CPU architecture, and I'm actually not that knowledgeable about different CPU architectures, right? But like, how many pages can we have in flight at once and things like that, right? And so if you've got essentially say you've got a 24 byte struct that you want to reference, and they're all scattered all over memory, then with very poor, what I assume data locality means, with very poor data locality, even if you prefetch 100% of the time, you're very inefficiently using those resources because you're only getting 24 bytes per fetch, right? And then everything else, like what's a cache line size on a modern CPU, right? What is even a current CPU? What are the CPUs that just came out? Like, what are the good AMD CPUs that just came out? 64 bytes is a typical cache line, right? Zen 2. $64 bytes per line. Okay. So if you're only reading 24 bytes out of that 64, then, or even let's say 16 or even 8, like you're chasing pointers, I don't know, right? Obviously, you're using a relatively small percentage of data that was fetched into that cache line, right? Now, if these things are sequentially in an array, then the next items are going to be in the same line, right? So you need fewer fetches, and your percentage of data that you're using from each cache line is maximized, right? Even if they're packed next to each other, but if you're going out of order, you may have evicted that line and have to fetch it again, between the time you got node number 1 and between the time you got node number 1700, which is packed next to number 1, right? There may be more issues than that. Like, I don't think about this kind of stuff very often in detail. I am not a super data-oriented design guy, ironically enough, because I spend most of my time at a little bit to a much higher level than that in terms of what I'm thinking and working on. But I'm at least vaguely aware of these issues, right? And think about them. So Zen 3 is coming up. This doesn't have the information. I don't know. Anyway, data cache line size. I don't know, man. It's probably in here somewhere. I don't see it. It's probably 64 bytes again. Because the problem is, if you make the cache lines too big, you get inefficiency. Because, like, maybe you're fetching too much data, right? And throwing most of it away for most cases. Maybe you've got more false sharing if your cache lines are bigger, right? So or maybe just with the architecture of the chip, it's harder to move more data at once. I don't even know, right? Not my area. You hear cache data locality in reference to cache optimizations. If it means data density, then you totally agree, but it always sounded like distance, which you could never make sense of. So some of this has changed over time, right? Like if you go back far enough, CPUs didn't really prefetch as aggressively or notice patterns as well, right? Like right now, if you bump a pointer forward by a constant amount or backward by a constant amount, or even I think you can do patterns of 2 or 3 and the CPU will realize what's going on. They didn't used to be as good at that, right? But I don't know. Like I don't want to try to make somebody else's argument for them. I would rather see them make their argument. But I think I would assume that the argument is that distance, like you're saying, if it means density, you agree, but it always sounded like distance. But distance kind of correlates with density, right? Like that's why, that's why the Unity ECS stuff, everything is like a packed array of a struct member, right? Instead of like even arrays of structs. Because when you have arrays of structs, you probably don't want to look at the other parts of the struct, right? So they're taking up part of the cache line and just making your cache usage less efficient. And so that's automatically distance, right? Like you can imagine your struct being exactly the size that you want for this particular loop, right? And then you start growing the struct by adding padding at the end. You're wasting more and more of the cache line. Maybe not even the whole cache line at first, because your next struct entry still shows up in the cache line, but at some point it doesn't anymore, right? But then after that, after one cache line worth of distance, it doesn't seem to matter, right? But for distances less than one cache line, it does matter. And cache lines aren't that big, so that range where it matters doesn't seem that big to me. But again, I don't think about this stuff all day, so probably people who do have a better answer. Unity ECS is just SOA all the way. Well, but there's also the component part, right? It's like what you get when you have SOA and components. There's also timing issues with bigger cache sizes because of physical size distance. Yeah, I believe it. Did I give any more thought to the function pointer with regard to a data pointer design question for closure-ish stuff? I think lightly about it every once in a while, and my conclusion, or I always think the same thing, is like, yeah, I should try that out. It sort of seems like the thing to do, but I've never like thought about it deeply enough because there haven't been that many more opportunities to think about it deeply. I'm going to eat a couple chips. Any last questions before I go to bed with my chips? No, that sounded wrong. We don't bring chips into the bed. That is not good. Is there some inherent problem in being able to make a 1 megabit CPU GPU bus? I don't know anything about that. I don't even know how fast they are right now. I mean, on the PC, you have to use common protocols that people could plug their GPU into right now, right? Which is like PCI Express times 16 or whatever it is. I don't know how fast that is. Thank you for the typo notification. Good point about servers. Yeah. Giant mess, dude. Giant mess. Is the language x86-64 centric? No, it is not. That is the only target that we are currently supporting. We have targeted ARM briefly in the past, and we will again. How many physical servers Dota has? Well, I think Dota is 1 game per CPU. Seriously. It's that bad. Probably some number of CPUs per physical machine, like 10 or 16 or something. I don't know. But like, if you know how many players Dota is at peak, divide by 10 to get number of CPUs. They probably have that many CPUs, and then divide by CPUs per box to figure out how many boxes. Do I think Sun Chips made me a better programmer? Absolutely. No doubt. This stream is sponsored by Sun Chips. Am I in favor of serverless computer? There's no such thing. When you think you have serverless code, there is actually a server running the code. Like, how can you succeed in the game industry if you have a snack deficit? Oh my God. I don't know. I mean, there's some things that I can't even help you with, right? I agree with George that cloud is a scam. Totally. He knows. He knows. Cloud is just a way to bill you more for something that should be much cheaper. That's all. Is there a way to avoid servers for the computation but still maintain large quantities of data marts and storage? I don't know what a data mart is. Is that like S-Mart? Shop smart. Shop S smart. Cloud is a scam, yeah. Do I think $299 a month is a ripoff for a basic CPU core and some storage? I mean, I pay a lot more than that. I pay hundreds of dollars a month for a co-located computer. So my question is, what are you actually getting for that $299? Like, is that a virtual host? Sounds like a virtual host if it's $299. All right, everybody, I'm gonna go to bed. Thanks for hanging out. We're going to do some more documentation. I don't know if I'm going to continue on this particular rant tomorrow during the day or if I'll do a different one and come back. But regardless, we'll probably do some more of this kind of stuff until I get annoyed at chat and hang up the stream. Thanks for coming by. We will do more. And I'll see you later.